In this little video, I just want to give you some tips regarding location or position versus time. And of course, we're talking about concentration always, right? Concentration of A depending on, and that's the actual trick. Typically, when we talk about something that changes with time, concentration with respect to time. Let's say a reactor, you will see a lot that time is a very important aspect. But we also have location. In a same reactor, we have, I don't know, let's say a long pipe. You know that if we got A plus B producing C, we know as the species go from left to right, you will see that we can get a reference with respect to position. Let it be X, Y, or more typically C. Now, I don't want to confuse you guys. We are still working with steady state, meaning that time is not relevant. But it actually is, because as stated before in the exercise, we use a time equals TF. What you will see in real life, let me go back to this case. What you will see in real life is that as time passes by, the molar fluxes will change. They will not be the same. So for me, it's kind of hard to not have this discussion, because steady state, yes, we are assuming steady state, but actually as time passes by, we are changing fluxes. And if we have fluxes changing, we have concentrations changing. Therefore, you gotta pay a lot of attention on time and distance relationships. For instance, why is concentration changing? And respect to what? Is it changing with respect to distance or with respect to time? Why is pressure changing? Well, we already know that concentration can be related with ideal gas law. So the same will be true with respect to time or position. And why the velocity is changing? Well, that for me is the most obvious one. Initially, when you have high concentrations, you will have a very quick diffusion. When you have low concentrations, you will have a very slow diffusion. But once again, remember the example of acceleration, velocity, and position. We are talking about rates of change. And well, this is the written, but it's what I was telling you. We are talking about location. Time right now is irrelevant. So please, I don't want you to get confused whenever we talk about timing. When we say initially or at the end or after a certain time passes by. So just try to relax. Don't try to force time right now. And you will see why later on. Actually, we are going to, if you wanted to see more on Fick's law, you will see that Fick's law can be modeled with time as well. But we're not going to see this in this course. This is more for a mass transfer or diffusion course.